Number one, initially in a 3-liter container, there's 1.2 moles of NO2. We're going to find all equilibrium concentrations. This tells me I'm going to need to do an ice chart because I have 2 different points in time. So I'm going to copy the reaction. And then I notice that I'm given a Kc value. And since I'm given a Kc value, I want to plug in molarity. So 1.2 moles of NO2 divided by 3 liters gives me 0.4 molar. 0.4 molar NO2 will go here. I have a 0 there. I know that the right side has to increase because it's the only way to go from 0, minus 2x on this side. At equilibrium, this will be x, and this will be 0.4 minus 2x. I'm going to now write my equilibrium expression with nothing plugged in. And now I can plug everything in terms of x. I know my Kc value to be 0.5. It's going to equal x over the quantity 0.4 minus 2x squared. The bottom, I'm not going to be able to square root both sides here, so I'm going to need to FOIL the bottom. That'll give me 0.16 minus 1.6x plus 4x squared. Now, cross multiplying, I'll have 0.08 minus 0.8x plus 2x squared equals x. Rearranging, and I'm going to write in descending order, I'm going to have 2x squared. 0.8x minus this x from this side will give me minus 1.8x plus 0.08 equals 0. At this point, I'm ready to plug into the quadratic. 1.8 plus or minus the square root of b squared minus 4ac, the whole thing over 2a. 2 times 2 is 4. Okay, so now I'm going to solve what I have under the radical. Plugging into my calculator, the square root of the quantity of 1.8 squared minus 4 times 2 times 0.08 gives me an answer. Now I have 1.8 plus or minus 1.61 over 4. I'm going to have 2 roots here. 1.8 plus 1.61, answer divided by 4 gives me 0.853. 1.8 minus 1.61, answer divided by 4 gives me 0.0475. I need to evaluate which root's correct. So I'm going to look at these 2 numbers and I'm going to see if I plug them back in for initial for in here and here, which one gives me 2 positive concentrations for all things at equilibrium. I can reject 0.853 because 0.4 minus 2 times 0.853 is going to be negative. So this root is looking good. So now I'm going to take that root. And here, 0.4 minus 2 times 0.0475 gives me 0.305. And here it will give me 0.0475. These 2 are my answers. I can check them by plugging back into my equilibrium expression. .0475 divided by 0.305 squared. That gives me 0.51, which is good enough.